You know, when a shoulder fails, fixing it isn't just about medicine anymore. It's a full-on engineering problem. And for years, two very different design ideas have been duking it out to see who could build the best replacement. So today, we're diving into the story of that battle, a high-stakes showdown between two designs, one called inlay, the other onlay. And it all starts with a problem that can make a person's arm almost impossible to use.
First things first, to really get what's going on, you have to understand the problem that kicked this whole engineering revolution off. We're talking about a condition that can pretty much leave a person's arm paralyzed.
So it all starts with the rotator cuff. You know, that group of tendons that holds your shoulder together and lets you move it around? Well, what happens when those tendons get a massive tear, one that just can't be repaired? The whole system breaks down. The arm bone, the humerus, starts to slide upwards and grind against the shoulder blade. And that's when a whole cascade of really painful problems begins.
Doctors have a name for this, cuff tear arthropathy, or just CTA. And it's a nasty combination of two things, really bad arthritis, plus a rotator cuff that's completely shot. For a lot of people, this leads to what's called a pseudo-paralytic arm. That means they literally can't lift their own arm up anymore. I mean, that's a huge loss of function, and it demanded a completely new kind of radical solution.
And the solution they came up with was, well, it was brilliant and totally counterintuitive. Instead of trying to rebuild a normal shoulder, engineers and surgeons decided to just re-engineer the whole thing from scratch.
Okay, so check this out. The idea was wild. They decided to just flip the joint's anatomy. So, in your normal shoulder, right, the arm bone ends in a ball, and it fits into the socket on your shoulder blade. Well, the reverse replacement does exactly what the name says. It swaps them. The arm bone gets a new socket, and a new metal ball gets anchored right onto the shoulder blade.
And this is what it looks like. This is the classic grommet-style implant. And you can tell right away it doesn't look anything like a natural shoulder, because it's not trying to be one. It's a machine, a piece of engineering designed to solve one very specific problem.
So why on earth does this work so well? Well, by putting that new ball on the shoulder blade, the whole joint center of rotation gets shifted inward. It's called medialization. And that little shift, it gives the big deltoid muscle on the outside of your shoulder a massive mechanical advantage. It's like giving it a much longer lever. The deltoid basically gets hijacked to become the new engine for lifting the arm, completely bypassing that torn-up rotator cuff. It was an absolute game changer.
But, you know, it's like any big invention, right? The first version, it's never perfect. You solve one big problem, and sometimes you end up creating a few new ones. And that sent the engineers right back to the drawing board.
I mean, giving someone the ability to lift their arm again was incredible. A huge breakthrough. But this first-generation design, it came with some trade-offs. It solved the main problem, sure, but it also created a few new, more subtle ones.
Well, there were a few things. For one, patients often couldn't rotate their arm inward or outward very well. There were also these background worries that making the deltoid muscle do all that extra work might cause it to get fatigued over many, many years. But the big one, the one everyone started talking about, was a brand new mechanical problem called scapular notching.
Scapular notching is pretty much exactly what it sounds like. Every time the patient brings their arm down to their side, that new plastic socket on their arm bone can clunk against the neck of their shoulder blade. And that repetitive impact over and over and over can actually wear away the bone, creating a notch and releasing tiny bits of wear debris into the joint.
And surgeons could literally see this happening on an X-ray. You could see the implant slowly chewing away at the bone near the bottom of the joint. And that problem, right there, that mechanical flaw, became the main reason for the next big wave of innovation. Which brings us to the main event. All right, so to fix the notching problem and that limited rotation, the engineers basically split into two camps. They came up with two competing philosophies for the arm side component. And this is where we get the big showdown. Inlay versus onlay.
So what's the difference? It actually comes down to one really basic thing, placement. The original grommet style is an inlay design. The new socket is kind of tucked down inside the top of the arm bone. The competing idea is an onlay design, where the socket sits right on top of the cut surface of the bone. And that one seemingly small difference, it changes everything, from your range of motion to the risk of complications.
So what's the first big trade-off? Range of motion. Remember how those early designs had really limited rotation? Well, the onlay was engineered specifically to fix that. And you know what? It works.
Study after study shows that people with onlay implants get way better rotation. They can do things like reaching behind their back or out to their side much more easily. But, and this is a big but, you don't get that extra motion for free. There's a twist. Some really cool biorobotic studies found something fascinating. Because that classic inlay design is tucked in more, it's actually more efficient. Your muscles need less force to lift your arm. So the takeaway is kinda, onlay gives you more motion, but the inlay design might be easier on your muscles over the long haul.
And the trade-offs just keep coming when you look at the complications. Onlay was made to reduce that notching problem, but newer inlay designs have gotten so much better that the risk is often about the same now. But then, one study found something pretty startling. Onlay designs might have a 2.5 times higher risk of a really serious complication, a fracture of the scapular spine. But here's the flip side. Onlay designs clearly save more of the patient's original bone, which is a huge plus if they ever need another surgery down the road.
And there's another long-term thing surgeons have to think about, called stress shielding. You know the phrase use it or lose it? Well, it's true for your bones. They need to bear weight and stress to stay strong. But if a super stiff metal implant takes on too much of that load, the bone around it is shielded from stress, and it can actually get weaker over time. It's just one more variable in this incredibly complex puzzle.
So after all of that, which one's better? Inlay or onlay? Well, it turns out that might be the wrong question to ask anymore. The real future of shoulder replacement isn't about picking a team. It's about building a custom one.
The reality today is that modern reverse shoulder systems are basically like a super advanced Lego set. Surgeons aren't just locked into choosing team inlay or team onlay. They can tweak the angle of the implant, they can add spacers to move the joint outward, they can use different lengths of stems, they can even choose offset parts to fine-tune the mechanics for each unique patient. I mean, just look at all these different options for just one part of the implant. This modularity gives surgeons incredible control. It lets them adjust muscle tension and perfect the implant's position right there in the operating room, tailoring the whole thing to that one specific person's body.
And this really gets to the heart of it, and it was summed up perfectly in a 2022 paper by Holliday and his colleagues. They basically said that just trying to lump all implants into inlay and onlay is a huge oversimplification at this point. The debate has evolved. The game has changed.
So, what's the final takeaway here? Look, that whole inlay versus onlay battle was hugely important. It forced engineers and surgeons to innovate and get smarter. But the real winner wasn't a single design. The real winner is the patient. Because today, the goal isn't just to pick the best implant, it's to build it. The perfect shoulder of the future isn't something you just pull off a shelf. It's assembled, piece by piece, uniquely for you.